So hello guys, welcome back to my channel, and today we are going to discuss about what is the difference between MLOps and AIOps. So it looks like they are same, and I would say when it comes to technology aspects, so both have a lot of overlap between them, but still they focus on solving a very specific problem. When it comes to MLOps, so it focuses on operationalizing the complete machine learning life cycle till production. And when it comes to AIOps, it focuses on automating the IT operations. So that's the fundamental difference. But I will talk more about how they differ and what are the different components. So let's start with MLOps basically. So why I am starting with MLOps? Because MLOps is very much mature and it is since long time in the market, and I'm assuming most of you already know MLOps. So that's where like it will help us in understanding the AIOps if we start with MLOps. So what is MLOps? So as I said, MLOps is nothing but it is the set of practices which helps in deploying machine learning model in production efficiently and reliably. And that's where it focuses on complete operationalizing the complete machine learning lifecycle. And that's where there are five most important components which are associated with MLOps. So as I said, it is basically related with the machine learning lifecycle. So that's where those components will also belong to individual lifecycle of machine learning stages. So the very first component of MLOps is like model development. So when I say model development, so it includes the model training and all the data related like data processing, data cleaning, data transformation, and then finally model training part. Okay. Then second, once model is trained, then second part is like versioning. So once we are ready with the model, then we need to version that. And along with the model versioning, we also need to version the data as well as the transform features. Because when it comes to reproducibility, that time, for example, a model is running in the production and we need to roll back it to the older model. So that time we need that data on which older model was trained and that older model version and then respective features. So that's where like if we need, there is a need to reproduce the particular model, so we need to version that. So that's where the second component is versioning, and it versions data as well as model. And the third component is like CI/CD. Once we have versions the model as well as the data, then we need to take it to the production, and that's where continuous integration and continuous deployment comes in picture. So that's where we build, we test, and then deploy the whole sort of code, complete pipeline. Okay. So this becomes the third component. And then what is fourth component basically? So once you deploy the model, then it comes to monitor that model, because it's not like any other software application. Model performance might degrade even in the very next step, right? Because there could be a change in the data. So that's where continuous monitoring of the model performance is required. And how you do that? For that, you need to have a data drift in place, model drift in place, all those things in place, and then we need to set up a complete monitoring pipeline. Okay, so this becomes the fourth component. And then last but not the least, last component is like the collaboration. And where if you are working with as the MLOps engineer, then you need to talk with DevOps, you need to talk with data scientists, and need to have a complete platform ready. That's where like DevOps, data scientist, data engineer can collaborate and work. So that's where this understanding of this terminology is very important. So these are the basic very important components of MLOps. Now let's jump to the AIOps, how it differ from the MLOps. As I have already told you that AIOps is nothing but it focuses on automating the IT operations. So that's where these components differ from the MLOps. So what are those components which belongs to AIOps? So when it comes to AIOps, the very first component is like data ingestion. As I said, every IT component or application generates a huge amount of data set. And there's a need to process, analyze that data, right? Understanding those patterns. So that's where the very first component tells, that is data ingestion, tells about aggregating that huge amount of data, then transforming from one format to another format, and then loading that data. Right? So you can say a kind of ETL operation, right? So that is the data ingestion part. So the second component of AIOps is nothing but the event correlation analysis. So when we have loaded that huge amount of data generated by IT application, we need to understand what are the different patterns, what are the hidden patterns behind the data, and what are the if there are any anomalies present in the data, if there are any outliers present in the data. So those sort of kind of analysis, correlation analysis, we need to perform among that generated data which we generated in the first step, and that the source was IT applications, right, which were generating the data. So IT applications are generating huge amount of data. Then what we do, we apply ingestion. So ingestion will load the data after transforming and aggregating, and then we do correlation analysis. What it does, basically, it tries to understand the hidden patterns and kind of generate the anomalies, basically, if there are any, basically. Okay, so this is the second component. And then what is the third component? Basically, it is nothing but the predictive analysis. When we say predictive analysis, so what it means, basically, so for example, you are analyzing the data. Okay, so you have some anomalies, you have some pattern, okay, and you have some logs, I mean, you have some bugs within that logs. Okay, so what predictive analysis or predictive maintenance here tells you, basically, you build those models which kind of in advance tells you, okay, if there is any bug is going to come. Okay, so then it will notify the respective developer or respective team who is going to solve. So that is one aspect. Another aspect could be, for example, if there are certain historical bugs are coming, and then there were certain kind of resolution for that particular bug, right? So if a bug is coming, then it will automatically suggest the, okay, this is the solution for that bug, and even you can automate that solution without going to the manual intervention. So if you do the automation, so that's anyway the fourth component after predictive maintenance or predictive analysis. The fourth component is like automation. So when your predictive maintenance is predicting, okay, this is the bug, basically, and this could be the response, and that's where using automation you can automatically fix that bug without a human intervention. So that's where it becomes very advantage and very cost beneficial, and even you reduce a lot of time, right? Because if it goes to the human intervention, then he has to first analyze, okay, what is the bug, what is the reason behind that, and then he fixes that. It's time taking, basically. So you by automation you are reducing that complete time. So the first component is like data ingestion, second is like event correlation analysis, third is like predictive maintenance or predictive analysis, fourth is like automating everything. Okay, and then fifth component is nothing but when you do the automation, then what is another most important thing, basically, so for example, in automation phase or predictive analysis phase, you identify, okay, there are certain bugs and there is a certain resolution for that, but it is also equally important to understand, okay, what is the reason behind those bugs, right? So that's where you do the root cause analysis. So that's where the fifth very important component, nothing but the root cause analysis. So you perform root cause analysis to understand, okay, the hidden so in the first step or in the second step itself, in the correlation, basically, you identify, okay, what are the hidden patterns and what are the anomalies, if there are any, right? So likewise, you do a root cause analysis. Okay, what is the reason behind this particular bug? Because you have a huge historical data available with you. So by analyzing that historical data, you can easily understand, okay, what is the root cause behind this particular bug, and you can fix that root cause, basically, so that in future it will not occur frequently. So that's where you're saving time, you're saving the cost, and your system will be up most of the time, right? So that's where like AIOps is nothing but it focuses on IT operations, automating the IT operations with the help of AI technologies, so that your application uptime is very high, and simultaneously, if there is any bug coming, then the resolution should be very quick. So these are the things, basically, AIOps helps in doing. So basically, applying AI technology in IT operations, automating IT operations is nothing but the AIOps. So that's where I have said in the starting, this name could have been ITOps. That suits more in this aspect, and that's why like people get confused. Okay, why MLOps? Why not MLOps coming here? Why there is again new terminology AI as a AIOps, right? So no need to get confused. As I already said, in technology aspects there are a lot of overlap, but AIOps focuses a specific domain, which is IT operations. Okay, so I hope I made it clear, and it is clear to you as well. And still, if you have any query or any doubt, then feel free to comment your queries, and then I will have to answer. So that's it for today's video. Thank you.